Hello everybody, welcome back. Before I go and tell you everything about recursion, prior to that, we need to know what happens in the memory when a function is called. Operating system behind the screen does lots of things in order to implement the function call practically. So we need to understand that what happens in the memory, what goes there in the memory when a function call takes place practically in runtime. So here you can see that we have an example here. We have the main function where I have declared these variables I, and there is an array x that is initialized with 3 values and a function and a variable sum. So from this particular point I am calling the fun1 function for some purpose. Now when the control is going to be transferred to the fun1 function, that means the function call is going to take place practically in the memory, then what the operating system is going to do, it is going to push all the information of the current function, that is the main function, into the stack. So operating system is going to create a stack in order to keep the details of the current function, because when we are going to the function fun1 from main is not completely done. After completing the call of fun1, the control is going to get back to the main. That means this particular line will be executed after completion of the fun1 function. So operating system needs to remember each and everything in the main. It needs to remember that there is an array x and the data item that is contained in array. There is a variable sum and I, what are the values there. So everything has to be preserved. The state of the current function has to be preserved. So operating system creates a stack and pushes all the information regarding the current function into the stack. So this is a stack. We know that stack is a data structure, that is last in first out data structure. Now a simple example of stack is a stack of books. If you go on stacking books one after another, then whenever you try to pick a book, you are always going to get the lastly placed book on the top of the stack. That's the property of the stack. The elements in the stack follows last in first out order. So stack is a typical data structure that can be implemented. So operating system builds this stack according to the instructions written by the compiler, and it pushes the status, it pushes the state of the current function into the stack. Here it is the main function's information will be pushed into the stack, and then the function called fun1 takes place. So then it goes to function fun1. So now when the operating system is executing this fun1 function, now there may be a call to another function fun2 from within fun1. It may happen. We may need to call some other function in order to do some other task from within fun1. So in that case, all the information of fun1 will be pushed into the stack. What are the variables there, what is the return value, and what is the next instruction that is to be executed in fun1 after completing fun2. So every information will be pushed into the stack by the operating system. So let me just write the fun2 for your convenience so that you can understand better. So we may have another function call here in our program. Say I'm calling the function fun1, and say we have a variable p equals to 10 here, and we are calling the function fun2. And again we are getting the return value from fun2, and we are doing something with the variable p after, say, we are incrementing. These are all fictitious. That means this type of codes can be there in your function. So I'm just writing that in order to make you understand that what happens clearly. Now I'm writing the fun2 function. So here we may need to do something. Say, okay, then ultimately a value is returned back. Say we have a variable k here, and we are doing some processing, and we are returning ultimately the value of k. Okay, that makes sense. So we are going to the function fun2 here. So all the information of fun1 is going to be kept into the stack. Then the control jumps to the function fun2, and on completion of the function fun2, what happens? The operating system pops the stack. So the top of the stack is fun1. So operating system gets to know that it was the fun1 function that was lastly called. So it removes every information from the stack. It gets back all the information regarding fun1, and continues from here after that, means and assigns the value back to P and then continues here. So on completion of fun1, again the operating system pops the stack and it gets the details of main, so it gets back here and it continues after this. So during the function call, whenever the function call takes place, each and every information of the current function that is necessary to keep will be preserved in the stack. So this is the phenomenon that is actually performed by the operating system behind the screen to make the function call successful. Now there are some situations when the stacking is not required. Practically it's not required. So for example, there are situations, I'm giving you another example. Say we have something like this. Say we have a function named fun3 and we made the call to the function fun3 here as the last statement of the main function. Now we are doing something important again in fun3. So here when we are calling to the fun3, we are going to the fun3, we can see that there is nothing left here to do in the main function. We are not using any variable after calling the fun3 function. So in this case, it's not legitimate to store anything for the main function, because after getting back from the fun3, we don't have anything left to do here in the main. Had we used any variable after calling fun3, that means something like this. Say I am writing a code to print, or I am doing something like this, say x0 equals to x0 plus 2. Then in that case, operating system would require to store the value of x, the array, into the stack. Then it would require to jump to the fun3. But since we are not having this statement anymore after calling of the fun3, when the fun3 completes, there is nothing left here in main. So it's not required to store the information of main anymore in this case. So in such cases, when the function call is the last statement and we don't have anything left in the caller function, then the operating system, then the compiler may skip the push operation into the stack and the operating system may not execute the stack operation at all. So it depends upon the compiler. Some compilers, if the compiler is clever one, all the modern compilers are so actually. So it skips the push operation into the stack in such cases when the function call is the very much last statement and there is nothing left after the function call in the caller function. So this is what happens during the function call in the memory. So we need to understand this in order to understand the recursion activity. So there it will be helpful. So thank you very much. Hope that you have enjoyed this.